entrepreneurship towards inclusive growth. And to start off the program, may I call on Dr. Jocelyn Labios to give us an overall recap of what has transpired during yesterday's session.
Thank you, Romnick. Now, I'm sure madadagdagan pa tayo mamaya. But it's a beautiful, beautiful sunny day. Medyo dumidilim-dilim ng konti. Open na po ang Starbucks. But it's not the reason why this day is beautiful. Well, just a thought I'd like to share. Is it just me or ako lang ba? Kasi parang there are two multinational companies right on the doorstep of the University of the Philippines, right in our faces. And the Filipino-owned company, somewhere further, yung Jollibee. But don't get me wrong, I'm not saying na hindi ako pupunta sa Starbucks pagka may bonus ang UP. Anyway, well, it's okay because UP does not own the land sa labas, outside the gate. We wish it does. We may be poor, but we are rich in excellence, which is partly shown by yesterday's activity. Oh, since Monday pa pala, di ba? We are really showing our excellence. And nabanggit kahapon ni Prof. Lilia na patikim lang yon. It's just the tip of the iceberg, sabi ng mga Amerikano. Kasi sa totoo lang, kailangan namin ilimit sa one presentation per unit kasi 9 na units na tayo. Plus 2 pala, yung CES and La Granja. So there's 11. And ang main idea is that sana, we wish that this is going to be a continuing activity every year. Parang pasimula lang to, just to show na, ay oo nga, parang we need a college-wide forum para marinig naman natin yung excellence na ginagawa ng bawat isa, hindi lang yung confined sa ating sarili-sariling societies. No? Which after the society meetings is in the proceedings, na who gets to see the proceedings, lalo na yung mga non-members, hindi naman lahat yan mag-access sa proceedings and things like that. But we are, like the papers that were presented yesterday, it's just, these are excellent work of research. So we are now on the 3rd and last day of our symposium. And we'd like to think this is just the start of something that's annually or semi-annual activity. And like yesterday, we're going to enjoy listening to and learning from 5 presentations of research breakthroughs and developed technologies from IWEP, NCPC, Institute of Weed Science, Entomology, and Plant Pathology, the National Crop Protection Center, the Institute of Animal Science, Dairy Training and Research Institute, and the Institute of Food Science and Technology. Yun po yung ang mga presentations po ay manggagaling sa mga units na yan. But before that, let me mention for those who were not here yesterday, that the papers presented were about the papaya ACC oxidase gene and how a patent was obtained for it recently. And it was presented by Dr. Pabs Magdalita of iCrops. And then presentation on the collection and characterization of Gabing San Fernando germplasm for animal feed, which is presented by Dr. Jose Nestor Garcia for Ag Systems Institute. And the third is the continuing work, presentation on the continuing work of our rice varietal improvement group in the college, which has been in existence for like 6 decades na raw, sabi ni Dr. Joe Hernandez, who presented it yesterday. And then, Dr. Heidi Galvez of IPB presented the genetics and genomics to effectively address host insect resistance in coconut, which is very important in light of the recent infestation which we had with coconut scale insects. And the last is the basic research, which is presented by a young assistant professor from the PhDRC, who presented basic research to prolong and maintain post-harvest quality of introduced fruit, which is becoming very popular, which is the dragon fruit. Now for today, the first presentation is by Professor Johnny Badijon of the Institute of Weed Science, Entomology, and Plant Pathology, who will present for his interdisciplinary team about the use of simple plant pathological techniques and some protocols to detect and diagnose viral infections in orchids. Uy, gusto to ng aking, ano, aking boyfriend, orchids. And some pioneering work on cacao diseases and distribution in cacao areas in the country. The second paper is to be presented by Dr. Hill Maxine. Yes, he's there. Who presents for his interdisciplinary team about the use of simple plant pathological techniques. Oh no, Asa, who will present for his team from NCPC and the Philippine Nuclear Research Institute, Doc Hill, a study on the use of carrageenan as plant food supplement in lowland transplanted rice. Well, do not be alarmed yet, especially you soils and crops people, because Dr. Magsino and his research team claim to have observed beneficial arthropods on carrageenan treated plants and reduced infection of Tungro virus and bacterial leaf blight in rice due to the application of carrageenan. We move from crops to animals with the presentation of Dr. Romel Sulabo of Institute of Animal Science. I hope he'll be here soon. For his team on their multi-stage research, we started with analysis of chemical composition of cassava, root meal, and using the results to develop prediction equations used in formulating diets for broiler chickens. Then our next presenter after him is Dr. Amado Angeles, who is with his D3 team evaluated potential feed sources for materials which have little to no economic value. This is banana stalk and water lily, but may benefit the dairy industry in the future. Well, our very last presentation for today and for the whole symposium actually is by Dr. Catherine Ann Israel, who will present for her unit, the Institute of Food Science and Technology, about their institute's thrust toward value adding to increase health benefits of food, enhance processing potential, especially with indigenous produce and more. Talking about healthy food, I believe, will be a perfect ending to our 3 days of coming together for this symposium. So, ladies and gentlemen, join me in learning from and enjoying this morning's paper presentations. Thank you.
Thank you, Dr. Labios, for your recap. So, for the regulation of our first session this morning, I would like to call on my colleagues from the Institute of Weed Science, Entomology, and Plant Pathology, Dr. Barbara L. Kawili as our moderator, and Ma'am Esther Magsino as our rapporteur.
Good morning, everyone. So welcome to the first session of CAFS R&D Symposium for today. So our first speaker is currently one of the energetic assistant professor of plant pathology in the Institute of Weed Science, Entomology, and Plant Pathology, and currently the assistant to the OIC director of IWEP. So to talk on diagnostics of insect viruses, please welcome Professor Johnny Balijon.
Thank you very much, Ma'am Bambi. 25 minutes. Okay. Wait lang. Kaya. Ano ba? Ba't yun na? Wait lang. Yun. Okay. Good morning, everyone. Okay. Good morning po, ma'am. Though I have been presenting several times in several conferences, I still feel quite uncomfortable presenting the output of our lab this morning from 2011 to 2017 with the dean watching and my first mentor in molecular plant pathology, Dr. Noli Vera Cruz, watching in the audience. So medyo kinakabahan ako kay ma'am. Okay. Ay, wag po. Okay, so this morning I will be presenting basically what our lab, the Host Pathogen Interactions Lab in IWEP, has been doing after my return from my master's degree from Erie. So this is a result of two major projects, one funded by DA Biotech and the other funded by USAID. Okay. So this is a simple outline of my presentation. First, I will, so that we are all on the same page. So the changing landscape of Philippine agriculture, followed by like recent pest incursions that we have experienced, and what reflections from IWEP has dawned over us in the past several years. Then our research on orchid virus diagnostics and VST diagnostics, followed by perspectives for future research, which are open to collaboration within the college, in the university, and mostly sa labas po. Okay. So by the way, nandito po, ayan, nandiyan na po si Tita Presi. Hindi ko alam kung nasaan po yung iba kong mga kasamahan, but Tita Presi is one of our collaborators for this project. So, as what Dr. Villarreal told us yesterday, then there was only rice and corn, right? But now, with DA's HVCDP program and Picard's industry strategic plans, we have several crops included for R&D. So we have diversified from rice and corn to the now, which still includes rice and corn, plus a lot of many, many more that we have to disperse our attention on. So this has triggered the concept of changing from farming as a production activity to farming as an enterprise activity, which entails some economic movement and thus movement of planting materials, probably with high yielding potential all over the country and maybe towards international borders. Okay. So for example, during our trips somewhere in the Philippines, specifically in Palawan and in South, in Mindanao, where there are so many areas for cacao cultivation, we have noted that there is a shift or a conversion, either unutilized land or currently utilized land, maybe coconut or rice, being converted into a lot of cash crops like oil palm or cacao in Palawan. And Del Monte, as far as I've learned, in 2015 or 2014, has some areas in Brooks Point, Palawan already for banana and pineapple. So it is expanding. Cacao is not only in Mindanao, it is crossing towards Bohol, Cebu, Camarines Sur, and southern Palawan as well, with Kennimer as the major player in this industry expansion. Okay, now, let's refresh a few years back. We have several enigmatic incursions. One, of course, is Brontispa, okay, which affected many of our farms, including coconut. The second wave of insect incursion was, of course, the famous coconut scale insects, which we know was of a different species, but the research needed to actually control not the pathogen, the insect pest, was only triggered after the incursion and the outbreak. So we were unprepared then, and we rushed. I wept, literally wept, from the pressure all over for us to provide what to do, whether to go chemical control, whether to go biological control. Then, a few years later, we have FOC PR4, which until now, wala pa ring economically feasible way to control except eradication. Then, a few years after that, there is another wave after the Yolanda typhoon of cassava witch's broom, which IPB again is leading the diagnostics and studying the basics on how to detect and diagnose and probably control or look at resistant germplasm for this pathogen. So in all four incursions, we were not prepared. Right? We have to admit. Okay. So what have we learned from IWEP? When we formulated the National Crop Protection Agenda, which CPC then headed, number one learning is to strengthen the basics. Strengthen basic research on pest or pathogen biology and diagnostics. As what has been previously taught to us in basic plant pathology, your management is only as good as your diagnostics. If you cannot detect properly, then you cannot manage. Kahit di ba sa health, RITM is there because of diagnostics prior to management. Second, collaborative research with countries that share similar crop or disease profile, which follows the adage, learn from other people's mistakes. Right? So we'll have to collaborate for those who have experienced a similar incursion. I remember Ma'am Bambi and Ma'am Sheng going to saan nga yun, ma'am? Indonesia, to look at a previous outbreak area for coconut scale insect during the height of this coconut scale insect infestation. The third, improve the efficiency of technology delivery systems to target clients, because our problem most of the time, we develop the product, but sometimes it is not adopted, or it is not properly, let's say, trained or passed on to the end users, which is frontline quarantine is not our function, it's BPI's function. So we usually have to pass on the technology to those clients. And the fourth, collaborative efforts between private and public partners to resolve pest or disease outbreak scenarios, which was the last resort during the CSI outbreak. Okay. Now, medyo seryoso. Baguhin natin ng konti. Okay. Just because you can't see it doesn't mean it doesn't exist. Okay. Medyo iba naman muna. So, orchids. So, nag-change na ng slide. Okay. So, orchids is one of the oldest and largest plant family. Okay. It's precious and highly valued in different cultures. So, it's in the Philippines. And one of the most ecologically and evolutionary significant plants. Right? Okay. So, one interesting thing that caught my attention when we started our research on orchid is this interaction or coevolution between the sphinx moth and the comet orchid. So, Agriecum sesquipedale and Xanthophan morgani. So, during the time of Darwin, in the Madagascar forest, Darwin discovered this comet orchid. You see the container of the nectar, it's so long, like 35 centimeters. So Darwin proposed then that somewhere in that forest, there is a pollinator with a proboscis that long to access the nectar below. But then, everybody didn't believe Darwin because nobody has seen an insect with a 35 or 30 centimeter long proboscis. That would be, the length of the proboscis is much, much longer than the length of the insect itself, right? So, in 2015, when we started the research, through infrared camera installed in the high canopy of the Madagascar forest, they saw a moth, a nocturnal moth, which stretches out a 35 cm proboscis to access. Only in 2016 or 2015, long, long before Darwin is dead. Yes, in the afterlife maybe. Okay? So just because they didn't see the moth, but there is evidence it doesn't exist. Okay? So this is proof that eventually it will be validated. Okay, now, in the Philippines, back to the orchids, there are basically two strata. The elite growers, which are capable of exporting and complying with the quarantine measures, and of course, the commercial growers, which sell like 30 pesos per potted flower. Okay? So most of the time, we prefer the breeders' selections, which are more aesthetically pleasing compared to the common dendrobium. So if you look at the conditions, this would have implications on disease transmission. Very crowded versus very well managed. So traditional plant pathology. Okay, now, our focus here is two viruses of orchids, which along with the fungal and bacterial pathogens are present in the orchid agroecosystem. So we have Cymbidium mosaic virus and Odontoglossum ring spot virus. Both RNA viruses. One is flexus, the other is rigid like TMV. ORSV is more stable and CYMMV is less stable, but we have found out that the titer or the amount of CYMMV in natural infection is higher compared to the more stable ORSV. Okay, now, along with our orchid viruses, there are a complex of fungal, bacterial, and rotting diseases, okay, that we have to sort out. Okay, now, the typical symptoms that our viruses induce would be this mosaic, chlorosis, and flecks or spots on the flowers, which could be mistaken as fungal or bacterial toxin-induced. Okay, now, what we did is to do a survey, a national survey in like north to the southern provinces, both wild and cultivated orchid areas. And we forecasted the incidence of single CYMMV, single ORSV, mixed CYMMV and ORSV, and negative infections. Negative detections, I mean. So if you can see, the total of for each province is 100%. This outweighs a single infection. And this has more similar trend to the infected. So on the average, there is at least 50% disease incidence. Because mixed and disease-free is almost of the same half. Okay, now, because we did a systematic survey, we were able to map out the entry points of the imported infected planting materials from 3 major airports. Of course, Manila, Cebu, and Davao. Okay? At some points, though in the conditions of anonymity, we were able to actually sample compats from, I will not tell the country, but compats imported, no comment, sir. Compats imported and shipped to the growers for transfer to the pots. Okay. Now, so there are also several important importers in yellow over there, which then pass on the planting materials to the growers. So konti lang talaga yung may importing capacity to clear up all those, and then they pass on to the secondary importers, and so goes the chain for the planting materials. Okay, now, what I want to talk this morning is actually a development of serological test strips, similar to the pregnancy kit type, for easier diagnosis. Because in virology, we usually have ELISA, we have PCR, we have indicator host assays. Okay, so here we have, for now, we have strips for CYMMV and strips for ORSV detection. Okay, so the presence of the band indicates positive detection, and the absence of the band, of course, indicates negative detection. Now, that was the final product. But for us to undergo that final product, we have to optimize several combinations of parameters, like the concentration of the latex microspheres, the concentration of the blocking component, the dilution of the sap for the testing, the concentration of the detecting beads, the incubation temperature, the support media. You see the Wattman qualitative filter paper. But now we are trying to develop a new strip using a different type of filter paper with a smaller pore size for better capillary movement. Then, of course, the distance of the immobilized particle from the bottom of the strip, which would affect the capillary movement upwards towards the strip. So these are more or less the optimized parameter. You can see which one is which. Okay? Then, we did comparative detection with traditional detection methods. So, from the orchid leaf sample, we divided leaf method. 4 sections for ELISA, tissue blot immunoassay, rapid immunofilter paper assay, and reverse transcription PCR, just to make sure that we are detecting at the same level of the virus concentration. So this is dot blot immunoassay, homogenized sap dotted on nitrocellulose membrane. Purple coloration indicates positive detection, and no purple, negative detection. Okay, so it's working. Of course, the classical. Okay, we were able to show that a wild Cassia occidentalis plant could be used simultaneously to detect CYMMV. You see here brown spots, bigger size, and ORSV, necrotic spots, but smaller pinprick sizes. So this host could be used to actually detect using the traditional couscous method. Okay. Then we have actually the actual blot of the sections to show the strength of the virus localization in the different leaf portions. So stronger purple sizes, high titer, lower, low titer. Because we have to classify our samples high, medium, and low so that we can assess the sensitivity more or less. Then of course the PCR, which we believe is the most sensitive. But in the case of orchids with so many secondary metabolites, we find it hard to isolate RNA. We have to isolate RNA because these are RNA viruses. So there are complications with the RNA. That's why we are looking at alternative methods, serological methods, which is not affected by these polyphenols and secondary metabolites. Okay, now, we compared immunofilter paper, symptom detection, ELISA, and RT-PCR, just for the purposes of comparison. So far, we have no problems with high titer. So this is arranged from high to medium to low OD readings. So 2 point something, a maximum OD reading of 3. 2 to 0.03, 0.1 is the threshold for positive detection. If it is 0.1 or higher, then it is positive. 0.1 lower is negative. So that's why you have here 0.037 as the negative control and 0.224 as the positive control. But Laguna 22, the Dendrobium sp is 2.325. Positive for ELISA, positive for RIPA, positive for RT-PCR. Okay? But RIPA has problems somewhere here. Low virus detection. But your RT-PCR look would have erratic results depending on the orchid species. May negative siya, na positive sa tissue blot, na positive sa ELISA. So that's the complications for the RNA extraction method. Okay, so we look at sensitivity analysis, diluting the SAP, diluting the SAP as well for enzyme-linked immunosorbent assay, tissue blot, and of course diluting the cDNA for RT-PCR. So in essence, we have this data. So sensitivity analysis, you can see that RIPA, okay. Wait. Okay, we diluted. So we diluted, right? So RIPA would have problems, low level and higher dilutions. Okay? Your RT-PCR would have problems erratically. So though this is low titer, it has positive. Though this is medium titer, it has negative because of the interference of the secondary metabolites. And tissue blot immunoassay using nitrocellulose membrane appears to be the most sensitive, up to 10 to the minus, 4, I think. So the dilution level affects the detection. Okay? So this is for ORSV. Okay? Since the virus titer of ORSV is lower, then we have problems detecting it in lower titer concentrations. Okay? Now, so what have we found? Okay, we found that RIPA is applicable for easy detection, but limits of detection need to be improved to accommodate medium to low virus titers. That's why we are moving to a different paper support. Second, ELISA is more suitable than RT-PCR for routine indexing of samples due to the interference of secondary metabolites during RNA extraction. That's why we recommend ELISA. But if this is for tissue culture purposes and micropropagation, we strongly urge everybody to use RT-PCR and optimize the RNA extraction protocol because it is the most sensitive detection for RNA viruses. So, careful examination of planting materials that will be reintroduced to wild habitats because I know IPB is doing this. They collect, they mass propagate, then they reintroduce. It has to be indexed because the lowland agroecosystems has very high virus infection, while the wild, there is no infection. So if we take out, we culture here, and then we return, we might be adding some bonus virus isolates along with the reintroduction, right? So let's be careful. Now, let's shift to the second topic, which is cacao. Okay? Cacao is a crop which is heavily cultivated 77% in the Region 11, the Davao region. So that's the focus of our study now. So in terms of consumption, basically baking products is the #1 source, okay, of the cacao byproducts. And the price of the dried beans so far has an upward trend rather than a fluctuating trend. So pataas. Okay, now, VSD, okay, is a pathogen that has been reported in South and Southeast Asia only. It is endemic to this region. Even though cacao is cultivated in Latin America, there is no VSD in Latin America, and there is no VSD in Africa. Okay? Now, the classical symptoms would be this: chlorotic spots, okay, and streaking of the vascular bundles. Okay. When we did a national survey from Luzon to Mindanao, these are the provinces, we have found similar vascular streaking, but a different leaf symptom expression pattern. Many of these are of the necrotic type, and only a few, symptom type B, exhibits the classical VSD symptom reported in South and the rest of Southeast Asia. That's the graph. Why? So we looked at, there is no classical VSD symptom. But can we detect VSD? Because in this case, the symptom expresses otherwise. Oh, sorry. Okay. So these distinct green spots or islands on infected leaves, to that, those are samples of my student from Kalinan district in Davao. So different expressions, we sample the entire twig. Okay? Now, when we isolated, the prominent symptom would be the cracking with the fungal outgrowth, the streaking, and when you plant on minimal media, there is a rapid outburst of fungal mycelia, which we don't know kung yun ang pathogen or maybe some more others. So, similar to the movie Inside Out, where in this case, the emotions of the child is represented by different persona, then the symptom expression might be varying because there are different triggers of pathogen infection inside. When we isolated the pathogen, we have seen like 12 or 13 associated pathogen, but when we rank them according to incidence, there are 2 or 3 which become predominant. So we focused on that. Okay, this is a vascular pathogen, and it is inside. So we cannot easily draw it out for isolation. We have learned that when you incubate the leaves in a moist chamber right after sampling, you will induce cracking and thus the exposure of the pathogen. Okay. By simple staining method of the isolation section of the agar, you will be able to see dolipore septation, which is the classical, okay, morphological trait for the VSD pathogen. Okay? We use specific detection for the pathogen, and we were able to detect the correct pathogen in these samples. But which samples? Okay. Staining, detection. We found out that Ceratobasidium theobromei, which is a nearly obligate pathogen, is heavily associated with Lasiodiplodia theobromei, which is a necrotrophic pathogen, which is screwing up the symptom expression to the necrotrophic response rather than the chlorotic response, which is typical for an obligate parasite. Thus, this detection scheme using PCR. All were almost associated with the Lasiodiplodia theobromei. Thus, you were able to forecast, okay, sure, VSD in Palawan and the Davao region. We have suspected in here, South Luzon and the Bicol region plus the north because the planting materials came from Mindanao. But we have not isolated and detected Ceratobasidium and Lasiodiplodia infections in Panay, Cebu, Bohol, and Leyte so far. So it appears that the movement of plant material guides, because this is grafted and this is vascular. Okay? So what do we intend to do in the near future? Pursue easy diagnostics for quarantine pathogens and for monitoring diseases in the field. Genome-based studies. We have started with coconut yesterday with Ma'am Hides. Genome-based studies of major pathogens affecting economically important crops. Okay? Because we now have the PGC. Priority crop-based approach in plant disease research. Because previously we are like organism-based. We have to move towards this. Of course, collaborative endeavors with colleagues from countries doing similar work or sharing of the same disease problems. And collaborative efforts between public and private entities to resolve disease problems, specifically in the case of vascular pathogens, which require systemic fungicides. So we have to access new compounds from the agrochemical industry. Okay? So funding agency, of course, my home unit, IWIP CAFS, PPPS, for being very supportive in all our endeavors, and of course, my workers from IWIP. Thank you very much and good morning.
So thank you very much for the very, very informative presentation. So do you have any questions regarding the presentation, yes, sir?
My name is Ray Villayan. I am with the Institute of Plant Breeding. I have a comment and a question. The first is the comment that, you know, that if you believe in second life, the moth with the long proboscis is Darwin.
Okay, sir.
Okay, I'm just interested in knowing what they mean by your future work on crop-based priorities. Because if I look at it, the way we are moving, you will again go back to rice and corn.
Yes, sir. Okay, so when we have, with the recent calls of proposals from, let's say, Picard and DA Biotech, if you have seen the memoranda, it is outlined there. These are our priority crops. Okay, so, like, of course, we work on orchid, but it is not an ornamental crop. But we are working on diagnostics. So we are trying to move towards the development of diagnostics with these viruses. Because we have the antisera. The antisera was previously prepared by Tita Presi and Dr. Bahet, long before I was in the Department of Plant Pathology. So, but the antiserum is still in very good condition. That's why we made use of them. So we can actually expand this to, let's say, development of these diagnostics in rice tungro viruses. Because there's also RNA and DNA virus, and there is antiserum, as far as I learned, because I came from the virology group of Erie. So we can expand to that line of movement. But when we resubmitted several proposals, we have seen that it's now priority crop based. So we have to work on diseases that address limitations in production for their priority crops. Like specifically, Picard is very strict on the industry strategic plant crop. So we submit proposals based on the crop-based. Because in plant pathology, sir, whether we like it or not, we're classified as a virologist, a bacteriologist, a mycologist, something like that. So our group, I was like, Ma'am Noli trained me for bacteriology and my master's professor trained me for virology. So I jumped. I could move from one. But most of us is like virology. The other is bacteriology. But with this priority crop-based, I think we have to move towards more collaborative efforts to complement each other. Yes. Yes, Ma'am Heights po.
So I'd like to commend you for a very interesting and really, ano to, parang broad kasi yung implication of your research. But I think one of the things that we should always remember or think about is developing the technology itself. And for you, the method for easy detection is there. So my question is, do you envision at some point that we will be able to develop a commercially available rapid diagnostic test kit for this kind of diseases or even virus?
Ma'am Heights, we are moving towards that direction. In fact, Tita Presi was part of the project, and we have actually initiated training or transfer of these findings to BPI. Tama ba, Tita? Many of our clients were BPI from different regional offices because previously, quarantined, PQS. So we invited them for training just to initially transfer, to make them aware that we are doing this. Because orchid importations are like a routine doon sa BPI. We don't have a stable orchid breeding program. In UPLB, only one group, the orchid nursery, is working on orchids. And many state universities, when the gap for non-food crops was being formulated, called upon us because we are the only university with an ornamental crops research which is functional. That's why Picard is moving towards the revival of the ornamental crops research, because nobody is working on that already. If you remember the Asian financial crisis, the efforts were moved towards all food crops. The ornamentals were left behind. But previously, the Department of Plant Pathology, I remember Dr. Divina Gracia, which is an ornamental pathologist. He's very strong ornamental crops research. But now we don't have. Yes, sir.
Johnny,
Po.
they have to get.
Ay. Wala pa po, sir. Wala pa.
Well, I can be your agent for a fee.
Talaga, sir.
First of all, I congratulate you. This is a very impressive
Salamat po, sir.
and a very impressive study. I'm glad also that you are campaigning for more ornamental studies in the future, because we really need this very badly, because we cannot rely on importing all the time on our material, and as we said, to include the photos and the import things. And many are smart smugglers.
Yes, sir.
Let us admit it, many are smugglers. There are a number of times I come from Thailand and I would be traveling with a number of ladies and their suitcases full of
Oh, yes, orchids.
without their lips.
Yes, sir.
But you know, at the quarantine, they will, because they were beautiful, they will smile only at the quarantine officer and everything goes. That's the way we do it in the Philippines.
Easy smug.
Right. My question is, you answered partly the first one about ornamental group that it seems to be a vanishing breed. In fact, even our ornamental here in the
Yes, sir.
the beauty of the orchids are no longer there, unlike during the time of Dr. Balmayor and
Yes, sir.
Dr. Gonzalez. All right. The next question is, who are people or scientists actively working on cacao, breeding, etc.?
Okay, sir. Cacao was actually a USM priority crop. So Dr. Sena, Romulo Sena, came from USM. And then, through this USAID program, 2 from UPLB were involved and trained in the US to work on these aspects of cacao production pathology. One is Prof. Salazar of horticulture, who worked on, I think, light transmission and intercropping density optimization of cacao in his mentor at the University of Hawaii. And I'm the second one. I worked on VSD detection with a USDA scientist at Beltsville, Maryland. So there's only 2 of us, young ones. The senior one is Dr. Potasio, I think. And the other, I don't know, but I know 3, Dr. Potasio, Bong, and may isa pa po, sir. So sa UPLB po, pinpointed.
Sir,
Yung.
ikaw at saka si Dr. Potasio.
Opo, si Bong po ang isa. Yun po yung ano niya, John Junior. Opo.
Okay. Thank you very much.
Opo, sir.
Well, if you need an agent.
Si Ma'am.
Okay, just one last question. Actually, this is not a question. This is I would like to commend you first, Professor John.
Salamat po. Natakot ako baka ma-disappoint si Ma'am sa akin eh.
Very proud. We are so proud. And he's, let's say, he's a BPI awardee for his thesis. Yes.
Undergrad po.
Yes,
Si Ma'am.
BPI,
Advisor ko
we're
po.
so proud. Okay, but I have a few comments. These are not questions. One, your detection method. They are so sensitive, but there is now a new technology. You are familiar about lump.
Yes, ma'am. Yes.
Look mediated. Also
Isothermal PCR. Yes.
That technology is mobile.
Mm-hmm.
You can bring it to the port of entry.
Mm-hmm.
So if you develop this technology, I think it will help you from the start, from the point of entry of the pathogen.
Okay.
So we can help you with
Yes.
that.
Okay po. Opo.
So next, after development of this protocol, you can actually move to transferring it. You're right. You go to BPI because they are the ones who are the possible end users of this technology. So you go to the end user. Now the other thing is really what you were talking about collaboration. This is really very, very important. We live on collaboration.
Yes, ma'am.
Scientists live on collaboration. Now, the other one is, are you familiar with the work going on in Ateneo? They are supported by Picari. Yes, yes, sir. Because they are developing a technology, they are collaborating. This is a collaboration between Philippines and California. Yeah.
Yeah, alam ko na.
Now, the group of Dr. Rina is collaborating with one of the universities in, I think it's Berkeley.
UC Berkeley.
In Berkeley, UC Berkeley. And so they develop a mobile technology like for microscopy. And they can bring it to the site. And then they are also developing other technologies that can actually literally allow you to look at the organism right there in the field.
Okay.
They have sensors, they have biosensors, so probably it's nice that you can discuss with them. And also, they are actually looking at management of fusarium.
Okay, yes.
Yeah, race 4.
Race 4,
You
TR4.
know how dangerous this pathogen is, in the banana industry. So probably, if you collaborate together, I think that will strengthen both
Yes. Salamat po, ma'am.
Okay, so with that, thank you very much, Prof. Burrito. But before we go, we would like to give you a certificate of appreciation. So we would like to call on Dean Supangco, Associate Dean Labios, and former Chancellor Ruben Villarreal. For the photo. So Dean has a very short announcement.
Good morning. It's also a challenge to IWEB. I was talking with the Vice Chancellor Rex yesterday, and I saw the picture of the pollinator. And I was telling them before that when I planted itong kalabasa, hindi nag ano, meron mga female, pero male, ayaw naman magtuloy. So sabi nila ay gumising daw ako ng maaga, kunin ko yung male. Dahil wala na raw pollinate. So yesterday, Vice Rex has agreed to provide funds to study pollinators. Okay, so I hope IWET can prepare a proposal. The funds are ready, but let us work together, go together with IPB, mga sa crops, I-crops, so that we can develop. Iniisip ko kasi doon yung end part, yung commercial part is we develop something, itong ano na to, na miski na nasa parang kahon ng posporo, ganun size. And then at a specific lifetime lang ano, ng isang vegetable crop, you will put it there in the field. It will develop and then tamang-tama lalabas siya during the time na flowering na yung vegetable. And you know, you have pollinate. Hindi na ako kailangan gumising pa ng maaga para mag-pollinate. Hindi bali sana kung ilang square meters lang, but if the farmers are, you know, 1 hectare, wala na siyang gagawin, kawawa yung misis niya. Iba yung pinopollinate niya.
Dagdag, the study of blooming habits is very important. About almost 50 years ago, I had my students study the blooming habits of several crops. They have to wake up very, very in the morning, about 4, 5, 6, so that they will be able to study the flowering habits of plants. And I think that's very critical, especially if you go into a commercial thing like what Dean Supangco mentioned.
So sir, after nyo mag-pollinate, pwedeng salad yung ano.
Isalad din daw.
Okay, so our next speaker is the director of the National Crop Protection Center here in UPLB, and he is the project leader for the evaluation of vegetation-modified carrageenan. And currently, he is the most senior, but the youngest at heart. Still in service with scientists in UPLB. Let's all welcome Dr. Leo Magsima.
Former Chancellor Ruben Villarreal, Dean Supangco, and to our R&D Symposium Coordinator, Dr. Joy Labios. To everyone, muli po magandang umaga sa ating lahat. Kahit man lang po sa damit, medyo bumata po tayo. Kina-counter ko po yung edad natin. So, saka ganito po talaga yung mga magsasaka na mumulot ng sirang pantalon kung saan-saan. Okay, so, this is one of the partner program of the National Crop Protection Center, and this is about carrageenan, the plant growth promoter and inducer of resistance to insect pests and diseases in rice. Quick review lang po, nakuha po natin sa kaibigan natin from URI, itong data na to. Ito yung latest data na nakuha natin. Quick review lang about global scenario. Okay, pagdating po sa population, masipag tayo. We have around 2014 data, Philippines 100.1 million, Vietnam is 92, and around 67 in Thailand. tayo po ay masyadong malakas kumain ng rice dahil staple food natin ito. At ang mga farmers, yan po talaga ang kalakasan ng farmers, no? The carbs from rice. Kaya lang mag-iingat tayo kasi yan din yung source ng diabetes. Okay, so globally, may data po tayo from our friends from Erie. Global per person, 65 kilograms. Pero may mas malakas pa rin po palang kumain kesa sa atin. So, tayo po yung pinakulelat pa rin kahit malakas tayong kumain ng rice. Philippines is around 120. Okay, followed by Thailand, about 140 kilograms. And then Vietnam, 215 kilograms. And Myanmar po yung pinakamalakas, 228. Patuloy po yung ating pag-consume ng rice, no, for the past several years. So about 65 million tons increase in the past 8 years. Keep on increasing. So, ito po siguro sa ating mga traditional, no, kasi yung mga kabataan ngayon puro nasa fast foods na yan. Siguro kayo bumababa ng konti. Now, anong implication? So, harvested area in millions per hectare, tayo naman po yung pinakamaliit. Based on data, we have only 4.7 million hectares, more or less, followed by Vietnam with 7.9 and Thailand 12.4. Malaki po yung kanilang area intended for rice production. Bagamat malakas-lakas silang kumain. Pero ang Philippines, malakas po tayong kumain, pero limited yung ating area for rice production. Okay. Now, with 2.4 million Filipino rice farmers with an average farm size of 1.14 hectare. I know, you know pretty well na ang ating rice farms in the Philippines, mabilis po yung conversion. No? Mabilis po yung conversion ng ating farm sa industrial sites, subdivisions, resort, etc. So, ano pong gagawin natin? Dapat we have to increase at least. We are not increasing our rice farm for rice production, pero at least we need to increase at least the yield per limited area. So, yan po yung aming isa sa objectives natin pagdating po dito sa ating project. So, productivity and sustainability is achieved through science and innovation. So, we would like to introduce the carrageenan technology for rice. Now, what is carrageenan? Simply, carrageenan is sa ating pong local dialect is a guso or gulamang dagat. Okay. And our partner, the Philippine Nuclear Research Institute, under our chemist, Dr. Lucille Abad, sila po ang nakadiscover ng technology of converting carrageenan into plant growth promoter. Nagkataon po ang National Crop Protection Center, tayo naman po yung nag-field verify nito. Kaya ito po, tumatakbo na tayo sa ika-fifth year ng ating technology. So, what they did is to break its particle down into very small pieces. And may reason, para po yung carrageenan, when you apply it to the rice plant, will be easily and efficiently absorbed. May isang slides pa po ako dito na I will discuss in more details. So, easily absorbed and consumed as plant food supplement. So, ang nag-discover po nito ay ang PNRI, and then tayo po nag-field verify, and some of the mechanisms, ginawa naman po ng field rice. Based on our application on registration with EPA, ito po yung ilan lamang sa mga information bakit nagko-contribute ng rice, increase in rice yield pagdating po sa ating rice production. Meron po tayong mga around 1.8 of the total nitrogen. Maganda po yung ating calcium, lalo na po yung potassium. We have copper, magnesium, we have iron. We are waiting for the EPA results on the plant growth promoters, the auxin, cytokinin, and gibberellin. Hindi pa po nare-release, pero nabigyan po namin sila ng methods on how to get it. And then from biotech, further, nagpadala rin po tayo. We have zinc about 35 and manganese about 5 milligram per liter. Ito po yung mga initial biological mechanisms or mechanisms on the biological efficacy. We found out that Carrageenan promotes root and shoot elongation. So kung makikita po natin, pointer. Ayan. Data po ito from Phil Rice. Kung makikita po, no fertilizer, pagkatapos po negative carrageenan, positive carrageenan. Between the two, pag hindi po natin nilagyan ng fertilizer, the synthetic fertilizer, makikita po naman natin yung greater volume of root formation. No fertilizer but with carrageenan. Comparing with fertilizer, okay, and then this is no carrageenan and this is with carrageenan. So nakikita po natin yung improvement of the root formation if we apply carrageenan. On the other hand, ito naman po pinapakita po natin dito about the plant growth promoting power of carrageenan. So, without any treatment, this is with carrageenan. Of course, this is with cytokinin and auxin. Bagamat statistically they are not different or they are comparable. Numerically, kung titingnan naman po ninyo, napakataas po ng coleoptile development contributed with carrageenan alone. Carrageenan increases the number of chloroplasts based on Phil Rice study, improving the quality of chlorophyll for efficient photosynthesis, increases yield by 15 to 30%. In-average lang po namin yan kasi sa ating multi-location trials, meron naman din tayo nakikitang lower than 15 but higher than 30. Sabi ko po kay former Secretary Montejo ng DOST, average na lang po natin yung range natin from 50 to 30%. Okay. Ito po yung why carrageenan able to absorb efficiently by the rice leaves. Kung makikita po ninyo, by nature, yung pong fresh extracts of seaweeds is a polymer. Ginawa po ng ating PNRI, they converted into oligomers, kapag carrageenan. Yung po yung kung bakit pag ina-apply natin ng carrageenan sa rice plants, this carrageenan will be able to efficiently absorb by the leaves. But we would like to inform you, ang ating pong seaweeds, no, ang ating source of carrageenan is not the fresh seaweeds, but the refined carrageenan. And PNRI, ito lang po hanggang dito lang yung masasabi ko, pero nakapag-patent application na ho tayo. Okay. Through E-beam technology of radiation, E-beam radiation technology, we were able to make this kind of manufacturing technology. Okay. So, carrageenan's plant growth promoter enhances stem strength, which may prevent lodging during extreme weather condition. Kung matatanda niyo po, last October 2015, about 3 years ago, nagkaroon po ng Typhoon Lando. Ito po yung area po namin sa Pulilan, Bulacan. Kung makikita po niyo, about 3 meters lang ang difference, no? Ang layo. Yung po may carrageenan treated sa farmer cooperator po natin, carrageenan treated after the Typhoon Lando, kung makikita po ninyo, tayong-tayo pa po at buo pa yung mga grains. Tayong-tayo pa. Kagaya po ng aking buhok, tayong-tayo pa po ito. Pero tingnan niyo po yung other field, farmer's field without carrageenan. Kagaya po ng buhok ni Sir, yung field without carrageenan. Dumapa na, dumalang na, pero sa amin po ay tayong-tayo pa. This is the reason why the former Secretary Montejo, DOST, na-encourage po siya lalo to fast-track the study and evaluation of carrageenan sa rice. Also, yung resistance, induction of resistance to pests and diseases, we are working on the principles of with proper plant nutrition. With proper plant nutrition, it can induce resistance to pests and diseases. Yun po yun. Sometimes we don't need the pesticides, but proper nutrition. So, kung makikita po natin, based on sa ating site, ito po may mga infection of tungro. At kung makikita niyo po yung ating field sprayed with carrageenan is still green. Another amazing information or data that we gathered, kaya lalo na naman pong ginanahan si former Secretary Montejo. Kaya po mula po dito ay pinahirapan na nila ang buhay namin. Marami na po siyang ginawang development. So hindi ko na po isasama dito because of time limitation. Okay. So of course, alam natin, ang Tungro virus is being carried by the green leafhopper. And then the brown plant hopper, somehow is carrying the bacteria blight. And ito po yung sinasabi natin, no? Lalo na po kasi nandun tayo sa on the height of promoting carrageenan among farmers nationwide. The technology itself will not work alone, cannot stand alone. So while we are verifying and promoting the use of carrageenan among farmers, we are emphasizing the importance of cultural management in rice. Lalo na po yung salaging, no? Yung salaging sa rice. Pag po mataas ang tubig, mataas ang nitrogen application, pagdating ng grain filling, konting hangin, dapa po yun. So, pinupromote po natin yung proper water level, particularly pagka po medyo nasa flowering stage na. And with the help of carrageenan, because of potassium in it, because of calcium in it, so napapatibay pa po yung stem. Kaya nung bumagyo, kung makita po ninyo, impressive yung results natin. So, yun po tandaan natin, no? As a researcher, as evaluator, balikan ho natin lagi yung cultural management being done by the farmers. Sanay na sanay po sila sa kanilang practices, pero sometimes they're not thinking the science behind the practices. Diyan po kailangan tayong researchers and extension workers. Tulungan po natin sila. Akala nila yung ginawa nila ay tama na. And would you believe, pag ikot po namin ng Pilipinas, wala pa siguro 1% ang farmers is conducting soil test analysis. Gumagamit po sila ng fertilizers that they want. Nasa kanila po yung desisyon. Ginagamit ang compadre, yung previous season. Tanungin po ninyo, bakit pa gumamit ng this number of bugs, this kind of bugs? Wala lang po. Isa po yun. That's why isa po sa aming objectives is also to train the farmers using our STK, soil test kit analysis. We're buying it from the soil science. Binibili po natin yan. Binibigay po natin ng libre sa ating mga farmers. Tinitrain po namin sila during the farmers orientation. And by the way, while we are doing it under field for verifying the efficacy of carrageenan, at the same time or simultaneously, we are doing laboratory or greenhouse studies versus Tungro and versus BLB. Alam naman po natin, no, yung Tungro for inbred rice, while as BLB sa mga hybrid rice. We're not only working on inbred rice, popular inbred rice, but also on BLB. Alam naman po natin ang BLB. Pag wet season, too much moisture, farmers tira-tira ng application ng nitrogen, in 2 weeks time, BLB. Isa po yan sa ini-improve natin. Of course, very difficult to work on BLB under wet season. Dry season, kaya kita nyo pag dry season, pinopromote ang hybrid rice. Primarily because to limit the infection of BLB. Pero we can do it during wet season. Okay? Yun lang commitment natin na ituro po natin yung proper cultural management with respect to the production of hybrid rice should always be there. Our technology will not work alone. As I've said, kailangan po holistic yung ating approaches pagdating po sa farmers. And believe na po tayo ng sorbetes. So, okay. So, kung makikita po naman nyo dito, no, yung ating technology is environmentally friendly and enhances the presence of natural enemies. Yung pong the red one, pinaliktad po natin yung red one, yung po yung presence of natural enemies. The blue one is the presence of the inimical pest, and the others are arthropods. So, makikita po ninyo in this carrageenan technology because it's organic, it's we are not promoting the use of pesticides. Kung makikita po ninyo sa aming mga pagkolekta ng data, very rich po sa natural enemies ang rice. Kaya kung konting lipad-lipad lang, sinasabi natin sa farmers, konting lipad-lipad, spray agad. No, we are teaching them to monitor first. Alam na alam po yan ng ating mga entomologists. Okay, sa ating po mga proper interaction, talaga pong suitable siya, no? Tininan po natin yan sa mga farmers who are using as high as 9 bugs. and then 6 bags on the moderate, and then 3 bags. And then 9-liter carrageenan per hectare per season, yun pong ating kasing recommendation. Okay, so, dahil malapit na po yung sorbitero, so, sa transplanting, we are using it, because this is organic, ang ating pong dosage is a little bit higher, 200 ml per tank load, 3 times application pagdating po sa transplanted rice, 12 to 15 DAT, 30 to 35 DAT, 45 to 50 DAT, with the corresponding growth stages. So, 3 liters, around 3 liters per hectare per application, for a total of 9 liters per hectare per season. Sa direct rice, sa direct seeded rice, ito po yung atin, 20 to 25, 40 to 45, 60 to 65. Okay, so ito po yung sinasabi natin with NPK 3 bags plus 9 liters, 1.09 lang versus 6 bags. Pero 39.56% over 9 bags alone if we have carrageenan. Okay, tinest po natin yung sa Pulilan. Ito po yung another season natin sa Victoria, Laguna. Still promoting or increasing the yield. Meron din po tayo sa Putotan, Iloilo with corresponding yield increase. Meron din po tayo sa Zamboanga del Sur. Kung makita niyo po, ayun po yung Abu Sayyaf, nagle-lecture. Okay. And then for commercialization, actually po at present, we received the provisional registration of using carrageenan as a foliar fertilizer. Not yet as PGP o plant growth promoter kasi wala pa po yung analysis as plant growth promoter. So as foliar fertilizer. And we are hoping that within the month, a-convert na po sa full registration ang ating carrageenan. We'd like to inform everyone na ang PNRI, sila po yung nagli-lead sa marketing ng ating technology. Kasi sila po yung naka-discover. So, naka-patent application na po ito. Meron na po silang 3 distributors na nag-aantay na ma-fully registered ang ating carrageenan. 2 minutes. So, with this, yung pong pagsisikap ni former Secretary Montejo and former Secretary Alcala, nagkaroon po ng MOA noong December 2016. Finally, this year, in-honor naman po ni Secretary Piñol, binigyan po tayo ng 50 million para po sa further field verification almost nationwide. Region 1, Region 2, Region 3, Region 4A, Region 6, Regions 9, Region 11. Napasama na po yung Cotabato at may sulat na request po si Congressman Dimaporo. So kasama na po yung kanyang Lanao del Sur pagdating po sa carrageenan. So, exactly 1 month, nagkaroon po kami ng inception meeting sa PICARD and to further verify the use of carrageenan into more or less 8 regions. So, personally, I would like to thank my team, Dr. Saldi Bayot, as study leader working on BLB, Dr. Filomena Santa Cruz of IWEF as my study leader working on fungal virus, and of course, my NCPC team, si Majel, si Lisa, si Jane, si Amiel, at ang bago ko pong members, no, hindi na po napalagay dito. Nandito po sila, si April, pathologist natin, si Freddy, kasama rito, si Freddy Webb, then si Karen, entomologist natin, si Marie Joy, then si Joy Mendoza, and si Melissa Montecalvo. Yan po yung ating mga new researchers, mga molecular biologists, kasi we would like to go deeper on our mechanisms, how carrageenan works. So, ito po yung ating kapartners, no? Ang PNRI, care of Dr. Lucy Labad, ang PhilRice. Of course, this is funded by PICARD UST and Department of Agriculture. Salamat po.
Thank you very much for the excellent presentation. So we're now open for question and answer.
Thank you, ma'am.
Here, congratulations. I think this is a very excellent presentation. My question is very simple. I know that the use of carrageenan will more than compensate, the cost will more than compensate the increase in yield more than compensate. The question is, how much does this additional cost of production if you use carrageenan in your rice? And is this only good for rice? How about other crops? So far as what you know.
Thank you, sir. Nalimutan ko pong mention because of the sorbitera. Okay. During our inception meeting, pinag-usapan po kami ni Director Ebora na wag muna kaming wag para hindi po ma-preempt yung price, but we can assure the farmers that it's very, very affordable. Kahit po 9 liters per hectare per season, murang-mura po yung pag na-market ito. Of course, ayaw ko pong sabihin yung cost, yung raw cost of the materials. Pagdating po kasi sa company, of course, and then, dito po sa ating palang 50 million budget coming from the Department of Agriculture, na nasa UPLB na po, nasa kanya-kanya ng ginawa po natin na imong budget, binahagi po natin sa DA Regional Directors and USC Regional Directors. Mahirap po kasi kung nasa lahat, hawak ko yung pera, ang hirap pong mag-sparse. Now, yung pong corn, expanded po ang corn. Kasi sa rice po talaga yung ating technology. Expanded po siya sa corn. Pero specifically, magkakandak po tayo within this April, starting April, sa Region 2 lang muna. Kasi Region 2 po yung heart and soul ng corn production. And of course, may duplicate po tayo sa UPLB. May standing po tayo ngayon na use of carrageenan in corn. So far, maganda po yung kanyang ipinapakita. So, yun po sir, rest assured yung ating farmers pag nasa market na ito, very, very affordable po ito. At again, katulad po na sinabi ko, supplementary po siya. Tama sir kayo, it could be an additional cost on part of the farmer. Supplementary siya kasi because of the NPK. Kailangan natin ng NPK. Soil nutrition, kailangan din po natin yung supplementary po siya. Kinumpita po natin ang economic analysis na tayo, very, very affordable pa rin sir. And in addition po pala, ang BSU, ginawa po nila akong evaluator, ginagamit po ito ngayon. Currently sa strawberry, sa lettuce, bell pepper, cabbage. Yan po yun, for vegetables.
Nakadali ko dito, no?
By age, Dr. Maxino, very impressive presentation.
Salamat po, sir.
Again, ng technology. Question ko lang number one, I'm sure yung comparisons na pinakita mong fields, they are the same variety, no? Baka kakuro. Sabi nga, ang bulong sa akin ni Dr. Vera Cruz, baka naman yung isa
matibay.
Talaga namang traditional variety, kaya hihiga talaga yan. At any rate, okay, that is good to tell them that you are comparing the same variety with the difference is the treatment. Ayan, ang talaga question ko ay, you said na paggamit ng carrageenan technology increases or give a potential increase of yield increase of 16 to 30%. Ang ibig mo sabihin, if the farmer uses hybrid rice technology and use carrageenan technology for the fertilization and supplemental growth innovator, very, hindi ko naririnig na mag-export na tayo ng rice. Pero ang bottom line is, talagang wala ng trabaho mga plant breeders. Sige, go ahead.
Hindi ba, sir? Katulad po naririnig ko since early this morning, kailangan po talaga pa rin ng mga collaborators. So, breeders will do their part. We are doing our part. Of course, NSIC 216 po yung ginamit natin sa lahat ng mga trials natin. The beauty of expanding this to 8 regions is to further verify the quality of performance of carrageenan to different rice varieties, different environmental conditions as well, and different attitudes of the farmers. Malupit ho yung kultura ng mga farmer, yun po yung tsatsagain po natin. But then we are, alam naman po natin, no, lalo sa mga extension workers, pagkaharap natin ng farmers, yes sir, yes sir. Pagtalikod, bahala kami sa buhay namin, basta meron kaming carrageenan. And for the information of everyone, libre po yung carrageenan natin. meron po tayong 30 million allotted for carrageenan production and distribution to different regions. Libre po yan galing sa Department of Agriculture from Secretary Piñol. Yes, ma'am.
Dr. Maxine, it's really very interesting and very exciting kasi itatanong ko po yung question na, kasi nakita ko kanina puro improve. Na-try na din po ba ito sa Cordillera?
Hindi pa po.
Kasi po, we have an ongoing project in the region, yung traditional varieties, urban varieties. Sila po, hindi sila nag-a-apply because they want it organic. So, pwede po bang i-try nyo doon para, kasi po, yung pinuproduce nila ngayon ay some of the varieties that is being taught or planned by the Department of Agriculture na i-export. And ang isang advance or benefit na gusto nila about those varieties ay organic. So hindi lang po yun, baka naman pwede ding i-apply doon sa ating mga varieties na nasa upland. Especially po yung mga pigmented varieties because they are actually now being preferred for export by Europe, US, because of the grain quality and nutritional value. Baka po pwedeng pagsama-samahin itong mga technologies na to. At saka, isa pa rin po, yung tinitingnan ninyong looking at yung agri-ecosystem. So, yung effect ng carrageenan, kasi nakita ko po kanina, it's irrigated. So, pwede din po natin tingnan, and also you're looking at the soil properties. Pwede din pong tingnan yung mga microbial composition. Pwede po tayo magkamero ng isang, if you want to propose it, yung project about yung microbiome.
Yes,
yes. So, I think all of this, if you put them all together, I think it will be a very, very successful innovation. Innovation sa inyong
Yeah, thank you very much, ma'am. Actually, ma'am, kasama po yung soil types, and then isasama po natin yun kasi yun din po yung base po sa our evaluators, si Dr. Paterno and Dr. Pompe Santa Cruz. So we will look deeper into that scenario. Ang ganito lang po, ma'am, may konting conflict lang tayo. Of course, we would like to use carrageenan organically sa mga organically grown crops. May problema lang po tayo based on our policy kasi po ang carrageenan ay irradiated. According to the PNS, pag GMO and irradiated, kahit po organic ang source, of course, lalo na GMO, hindi yan. Pero yung sa atin sana, kasi po una kong ini-apply for registration ang carrageenan sa BOPS. Kasi po kami evaluator and consultant din sa BOPS. Pero sumuko na ako nung sinabi nila, pag policy po, surrender agad ako pag sinabing policy. Because it is irradiated. But I explained to them, kahit hindi po tayo chemist, napupulot ko lang po sa ating kaibigan from PNRI, ang sabi po nila, irradiation is just purely heat, extreme heat, no chemical use, etc., etc. Pero dahil radiation technology, hindi po siya considered as organic. Kaya hindi po, pwede pong gamitin kung sino mang farmers, pero kung for export, hindi at nilagyan po ng carrageenan, baka po hindi tayo makapag-export because sasabihin po ng BOPS, hindi po organic ang carrageenan. Kaya po organic yung source. But the process is radiation. So, nasa PNS po yun. Ayan po yun. And would like also to inform, ang PNRI naman po, nag-conduct din po sila ng mga trials sa mung bean at saka sa peanuts. Yun po yung kanila naman simultaneously with our rice. Gumawa din po sila sa soybeans, sa peanuts, para po mapatunayan din yung performance. Alam nyo po, yung sa kanilang mung bean, 300% increase in yield sa mung bean using carrageenan based on their data. So, ayun no. Kaya sabi ko lang kay Secretary Montejo, conservative lang po tayo, 15 to 30. By the way, sabi ko nga po sa inyo, still, our technology, specifically carrageenan, we need favorable environment as well. Bumababa po tayo sa 15, may 8, may 10, minsan 5%, nung na El Nino tayo. Pero with very favorable conditions, naka 65% yield increase tayo with a limited area. Kaya po nakita rin natin talaga dito yung climate change really affected our technology. Kaya po holistic nga yung pagtingin natin. Pero kami on our part, we are very much interested in the soil types and the microbes na nandun. Yes, sir.
Anong yield ba pinag-uusapan natin? What kind of yield level are we talking about?
Tons per hectare yield, sir. Tons per hectare yield.
Pero ilan nga? We are talking about 6%, 60%, and everything. Ano ibig sabihin nga?
Okay, sir.
Ano ang benchmark mo as the yield to yield?
Kasi, sir, of course, nagva-vary no? Pero on the locations that we have, kasi meron po tayong Karajinan alone, supplemented with Karajinan and the farmers practice alone. So, yung po mga farmers practice alone, meron po silang 3.8, 4.5 tons per hectare. Tayo po, 5.5, 6 tons. Apo.
Okay, so Ms. Matsima.
Magtatanong po yung sorbitera.
Yes,
Sa
ma'am.
isang litrong Karajinan na for application na, for formulated product, ilang kilong puso?
This is a refined Karajinan, actually. Refined Karajinan. So, PNRI na lang yung nakakaalam ng technology how to do it. Kasi sabi nga, hindi kami pwede mag-disclose too much kasi patent application pa. So, basta refined Karajinan yung ginamit. Not the kilograms of the fresh seaweeds. No, it's not that. It's the refined. Yes.
Thank you for your very interesting discussion. Instead of questioning, I would like to make some comments. I'm a forester, a retired professor of the College of Forestry here, and researcher at the Ecosystem Research Development Bureau of the DNR. Now, I attended this because I want to learn about agriculture. I'm a forester. So, now after hearing the results of researches and training of you people in agriculture, can we not coordinate with each other? For example, here in Mount Magilin, instead of farmers clearing the area and planting rice and corn and vegetables, why can they not? Why can we not train them? Give them the solution, this is called agroforestry, combination of trees and agricultural crops. Not rice, not corn, but possibly fruit trees, pineapple, vegetable, so that these agricultural crops will grow, will produce the expected amount of production even between or under the trees. So that we have we have a combination of production income from our mountain areas. We have the income from the trees, we have income from the agricultural crops. But most important is the effect on the environment and the people there in the mountain and below the mountain. Because if we continue allowing farmers to destroy the forest, terrible. I was in the logging industry for 11 years. I feel guilty when I hear from the radio and see the TV the effect of floods, strong winds that come to the that visit the Philippines, and while we are still alive, why can we not do something together so that we can protect the people and the environment? Thank you very much.
Well noted, sir. Thank you, sir. Well noted po.
So we would like to call on Assistant Dean, Associate Dean Labios, and also former Chancellor Rivera.
are the certificates of appreciation and our small token.
Thank you very much to our research persons. Before we start, so that ends our first session for today. We'll have our second session at 10:15. At 10:15, but before you go for the health break, well, we actually have coffee snacks outside at the lobby. We will have photo documentation, so group pictures for this session. Okay, before we go for our health break.